By now you've probably heard about the controversy surrounding the slow SSDs in the M2 Max. So in this video, I'm going to break it down and explain the issue and give you some advice on if this is actually going to impact you and if you should consider upgrading the SSD or the RAM. First of all, what is all this controversy about? Well, in a nutshell, the base model SSD on any Apple Silicon Mac with an M2 chip is noticeably slower than the previous M1 version, and even the older Intel versions. This includes the 256GB SSD on the M2 Mac Mini, MacBook Air, and MacBook Pro, and the 512GB SSD on the M2 Pro and M2 Max chips. How significant is this speed difference? Well, here's a disk speed test showing the difference between an M1 and M2 256GB SSD. The M2's write speeds are much slower, and for read speeds, the M2 sees a whopping 50% decrease in performance. If I put this data into a graph, you can see the massive difference between the two represented visually. And for comparison, here's a 2016 MacBook Pro, which is 7 years older than the M2 Mac I'm comparing it against. So why are the base model SSDs on the M2 chips much slower than the M1? Well, let's take a closer look. Using the 256GB SSD as an example, on the M1, there are two 128GB NAND chips for a total of 256GB. But on the M2, there's just a single 256GB NAND chip. Now, having two different NAND chips instead of one big one is the major difference here, because having two allows each chip to connect to the M1 or M2 controller separately and fill two data buses in parallel. Bus is in the communication system that transfers data between components in a computer. It's kind of like a highway for data, and having two lanes on a highway allows for more traffic, or data to be transmitted compared to just one. The 512GB SSD on the M2 Pro and Max chips is a similar situation. They use less individual SSD NAND chips, resulting in a slower speed. So now that we've established the M2 base model SSDs are significantly slower than previous versions, is it actually going to impact your performance and your everyday usage? And should you even care? Well, if you're just doing everyday tasks like browsing the internet, sending emails, or using Word documents, or even some more intensive things like editing photos and videos, as long as it's nothing too crazy and there's not a lot of background apps open, I seriously doubt most people will notice or care. However, in some slightly more demanding situations, it does have a negative impact, like reading or writing a large amount of data to the SSD, or particularly once you start to multitask and use programs that require a decent amount of RAM, which results in your Mac using something called swap memory. Quick crash course on swap memory. It essentially allows your computer to run faster and multitask a bit better. And it achieves this by moving processes and apps that aren't currently being used out of physical memory, which is your RAM, and onto virtual memory, which is essentially just temporarily writing and then reading this data from your SSD. As you might expect, a slower SSD will have an impact on this process. And in some situations, some, not all, it depends what exactly you're doing, the previous M1 chip will actually outperform the newer and more powerful M2 chip. All because of the SSD speeds, which just should not be happening. So, what is the solution to this problem? The only thing you can do is pay extra to upgrade the SSD or the RAM. And if you upgrade the 256GB SSD to the 512GB version, that means the Mac will ship with two 256GB NAND chips, which resolves the slow speed issue. Alternatively, by upgrading the M2 Pro and Max chips to 1TB SSDs, this will give you similar speeds to the 512GB M1 Pro and Max. Or by upgrading the RAM, the apps and processors on your Mac don't need to use as much slower swap memory, so performance will be better. And this is much more noticeable on the standard M2 chip, going from 8GB of RAM to 16GB of RAM. For example, exporting some photos while multitasking with several apps open in the background versus no apps open in the background. You can see a significant decrease in performance with the 8GB RAM M2 Mac, but the 16 and 24GB versions see almost no difference when multitasking, simply because they have more RAM available for the Mac to take advantage of. And if you only have the money for one upgrade, I recommend upgrading the RAM. Sure, by upgrading the SSD, you'll get slightly faster read and write speeds and obviously more storage space on your Mac, but simply having more available RAM is usually the best option. And don't forget, you cannot add more RAM later, but you can use an external drive if the SSD is too small. Now, all of this begs the question, why did Apple do this? It makes no sense to use an inferior storage solution when releasing a new and improved version of an existing product. The short answer is, Apple is never going to tell us. But we can speculate. It's very likely that Apple is simply cutting costs and improving their profit margins. And it wouldn't be the first time either. I mean, these are base model products and most users likely wouldn't have even noticed. It's also a great way to force customers to purchase upgrades to squeeze more money out of them. It could also be due to some of the supply chain and component shortages out there. Like when Apple's main SSD supplier lost 6.5 billion gigabytes worth of their NAND flash storage last year due to contaminated materials. But what do you think is the reason? Pure greed from Apple? Do most people even care about the slower SSD speeds? Well, I'll leave that up to you to decide, but let me know what you think in the comments section down below.